Today we will discuss about root locus. What do you mean by root locus? In the preceding chapter, we discussed about the relationship between the performance and the characteristic roots of the feedback system. The root locus is a powerful tool for designing and analyzing the feedback control system. It is a graphical method by determining the locus of roots in the S-plane as one system parameter is changed. Then what is the root locus and why it is needed? Fact 1 is poles of closed loop system are an important key to describe a performance of the system. For example, transient response as we discussed in the last chapter, that is a peak time, percentage of overshoot and the rise time, as well as the stability of the system. Factor 2 is the closed loop poles are the changed when will vary the gain. And the implication is root locus is nothing but paths of the closed loop poles as a gain is varied. What is the root locus concept? Definition of the root locus is the root locus is the path of the root locus of the characteristic equation of the system traced out in the S-plane as a system parameter is changed. The root locus and its system performances is based on the stability, dynamic performance of the system and the steady state error of the system. The basic task of the root locus is how to determine the closed loop poles from known open loop poles and the zeros and gain by root locus equation. There are some requirements, that is angle requirement for the root locus, that is a necessary and sufficient condition for the root locus, and magnitude requirement is gains evaluation for a specific point of the root locus. We'll discuss some properties of the root locus. First property of the root locus, that root locus diagram is always symmetrical about the real axis of the S-plane. And this is another two properties with respect to the angle. What is the procedure? We will discuss the procedure for drawing the root locus firstly, and then we will solve some examples based on the root locus. We know what do you mean by the characteristic equation. Characteristic equation is nothing but 1 plus g of s into h of s. F of s is nothing but an equation which will be provided for the any closed loop system. Then firstly you are supposed to write down the characteristic equation 1 plus f of s or 1 plus g of s into h of s is equal to 0. After writing the equation, you are supposed to find out the how many poles and how many zeros are present in the particular equation. Then step number 3 is locate the number of poles and the zeros with the specific symbol and draw it on the S-plane. Step number 4, the root locus on the real axis lies in a section of the real axis to the left of an odd number of real pole and zeros. Step number 5 is the number of separate loci is equal number of open loop poles. Loci is nothing but a real locus. Step number 6, the root loci must be continuous and symmetrical with respect to the horizontal real axis. Step number 7, the loci proceed to zeros at infinity along asymptotus centered at and with the angles. These are the two different formulas for finding the angle and asymptotus. Asymptotus is designated by sigma and angle is by phi. These are the formulas we are going to use at the time of solving the example. Next, step number 8, the actual point at which the root locus crosses the imaginary axis is readily evaluated by using the root criteria. As we have discussed in chapter number 4, stability criteria. With the help of root criteria, we can find out the stability of the system. Next, step number 9, determine the breakaway point. Here it is, with the help of this formula, we can find out the breakaway point for the root locus. Usually, breakaway point is on the real axis. Next, step number 10, this is nothing but a determination of the angle of departure and angle of arrival for the phase angle given for the particular system. These are the formula with respect to the angle of departure and the angle of arrival. This is denoted by the theta p and the phi z. We'll use this formula at the time of solving the examples. Next, step number 11, plot the root locus that satisfies the phase criteria. Phase is denoted by the angle of P of S is equal to 2 into bracket 2k plus 1 into 5. You can vary the k from the 1, 2, 3 up to the infinity, and you can find out the angles for that. Then next step, determine the parameter value k1 at a specific root using the magnitude criteria. This is the formula for calculating that. We have discussed some steps with respect to the how to form the root locus. Now we'll discuss the how to construct the root locus. First, you have to find out the loci branches. Then you have to draw it as in steps we have discussed about. You have to find out the number of poles and the number of zeros. Find out that whatever the loci we have discussed, that red line is nothing but a real loci. This is the construction for the root locus. Next, how to find out the asymptotus angle. And that whichever the formula is given for finding the root asymptotus angle, that is a theta. Formula is 2k plus 1 in another in a bracket pi divided by n minus m. We can vary the k is again from 0, 1 to up to the infinity, and with the help of that we can calculate the theta. Here it is, we can consider n is n and m is the number of poles and the number of zeros. If the number of poles are the 6 and number of zeros are the 2, then theta you are supposed to calculate with the help of by varying the value of the k. The next one is angle of departure and angle of arrival. With the help of this formula, phi of d and the phi of arrival. D stands for the departure, A stands for the arrival. 180 plus angle of G of S into H of S, and the angle of arrival is 180 minus angle of G of S into H of S. With the help of formula, we can calculate the angle. In the example, we will discuss in a detail how to calculate the angle of departure and angle of arrival. Then the next point is calculate the break away point or the break entry point for the particular closed loop system. Then with the help of this equation, we can calculate whatever the system is provided for you. With the help of that system, you have to first find out the value of the k, and then take a first derivative of that, and then find out the particular entry point. Then here it is, we have taken one example. Example is equal to k divided by s into bracket s plus 1 in another bracket s plus 2. Then as we know, we have to take a characteristic equation for that. 1 plus k into g of s into h of s is equal to 0. Then after this, we have to solve this equation for the k. Then after solving, I got this k is equal to minus into bracket s raised to 3 plus 3s square plus 2s. Then take a first derivative of it. Minus 3s raised to s square plus 6x plus 2 is equal to 0. And with the help of the finding the roots, find out the roots for this. S is equal to, then with the help of the root formula, that minus b plus minus root or minus b plus minus root over b square minus 4ac divided by 2a, we can find out the roots of that equation. That roots are s is equal to minus 0.423 and the minus 1.577. These two are the breakaway, the entry points. Then, as we discussed in the steps, we have to calculate the centroid of the asymptotus, denoted by the sigma. It is another, we will discuss this with the help of example. What is example? G of s into h of s is equal to 3s divided by s plus 2 in another bracket s square plus 6s plus 18. Then we'll calculate how many zeros are there, how many poles are there. How many zeros are there? 1 0 is there, that is a 0. How many poles are there? 3 poles are there. Then we have to consider the formula for finding the centroid edge. Sigma is equal to summation of poles minus summation of zeros divided by n minus m. As the number of poles, n is equal to 3 and the number of zeros 1. Therefore, at the denominator side, 3 minus 1 is. At the numerator side, we have to consider the summation of the poles, that is the minus 2 minus 3 plus j3 minus 3 minus j3 minus number of poles is a 1, and that is at a 0, therefore 0. Here it is, we'll calculate the centroid for that one, that is nothing but a sigma is equal to minus 4. Then Already we know the formula for calculating the angle. Theta is equal to 180 divided by 3 minus n minus m, that is nothing. Theta is equal to 90 degree. We have discussed about what do you mean by root locus, what is the use of the root locus, then what is the concept of root locus, what are the steps and how to construct the root locus. Then here it is, we'll discuss actual example with the help of that construction rules and the steps. This is an example given for drawing the root locus or finding the stability of the system. Then here it is, equation is given, k into g into h of s is equal to k divided by s into bracket 1 plus 0.5 s in another bracket 1 plus 0.1 s. As we have discussed in a step, we'll first find out how many poles and how many zeros are there. Then this is nothing but a poles and the zeros. The next step is find out the sigma, that is nothing but a centroid, that is the is equal to number of zeros, number of summation of the poles minus number summation of the zeros divided by n minus m. Then here it is, we got the answer is sigma is equal to minus 4. Then we have to calculate the theta also. 180 divided by 3 minus number of zeros, number of poles. Here is number of poles are 3, number of zeros are 0. Therefore 3 minus 0 is equal to 60 degree. Next, third step is you have to calculate the roots. Then same procedure as we had discussed at the time of solving at the time of finding the centroid or the breakaway point. Consider the equation, find out the value for the k, and then take a first derivative of that and find out the roots for that. Then, as we are having the equation for that, find out the stability for that and find out the value for the k. Here it is, value for the k. We can calculate the value of the k for the particular example with the help of the root array criteria, as we are discussed in chapter number 4. Here it is, for this example, you got the value for the k is equal to 12, and then here it is, s is equal to plus minus j 4.5. It means that root locus will cut or intersect the imaginary axis at plus minus j 4.5 at k is equal to 12. And this is a diagram. This is a root locus diagram. Here it is, as we have discussed for this example, how many poles and now how many zeros, we have to draw it on that s plane. Then we have the centroid, sigma is equal to minus 4. You have to point out that also. Then we got the angle as a 60 degree. We have to draw the line from that centroid minus 4 to the imaginary axis. Then we got the intersection of the imaginary axis. It is on the in between 0 to minus 2. We got the 2 s is equal to minus 7.05 and the minus 0.945. Then minus 7 point, it is not valid, that is s is equal to minus 0.945. It is a valid because it is on a real axis, that is in between 0 to minus 2. So point out that also. Then point wherever that imaginary axis is going to cut the particular point, that as we have calculated with the help of root array, that is s is equal to plus minus j 4.5. So that particular point will be intersect the imaginary axis at j 4.5 at the upward direction as well as at a downward direction, as we got s is equal to plus minus j 4.5 at k is equal to 12. So very simple example. Then we can draw the root locus diagram with the help of MATLAB also. Very simple. Equation is the RL2, that is a GH, or R locus is another syntax for drawing the root locus with the help of the MATLAB method. We'll discuss another example. Sketch the root locus for the particular diagram. First, you have to find out how many poles are there, how many zeros are there. Same procedure. Then we have to use the formula sigma is equal to summation of number of poles minus summation of number of zeros divided by number of poles minus number of zeros. Here number of poles are 4 and the number of zeros are 1. Therefore 4 minus 1, that are at -1, -2, -4, and another one is at a -3. Therefore sigma is -4 divided by 3. Then you have to calculate the theta. Formula for the theta is 2k plus 1 into pi, or the 180 divided by p minus z. For the particular value of the k is equal to 0, 1, 2, where we can calculate the number of angles, that is the theta 1, theta 2 and the theta 3. That is pi divided by 3, pi, and the pi 5 pi divided by 3. Here it is, easily we can calculate by putting the value of the k as a 0, 1 and 2. This is the first part of the diagram. Here it is. As a root locus, we got in between 0 to -1 and -2 to 3, and the asymptotus is another -4 above the -4. Then you have to calculate the sigma. We have calculated the sigma is at a -4 divided by 3. Here it is a calculation for that. Then angle, we are having the angle, 3 different angles are there. We have to draw the diagram for that. And then with the help of root array, we can calculate the value of the k and the where that particular centroid will cut the or intersect the imaginary axis. We'll discuss another example, k divided by s into bracket s plus 20 and the bracket s square plus 4s plus 20. Procedure of the steps are the same. First, find out the root locus, how many roots are there, how many zeros are there. Then you have to calculate the sigma. Then calculate the angle of departure angle, breakaway point, intersection on the imaginary axis. Same procedure you are supposed to follow for all. And this is a diagram final for that. Real locus, that is 0 to -20. It is shown in the diagram. Then asymptotus sigma is we got at a -6. Two different angles we are having, plus minus 45 and the plus minus 135. It's shown by the blue line. Then angle of departure is theta is equal to -39 degree. Then we calculate the breakaway point D and the angle. Then we have calculated the intersection point on the imaginary axis with the help of root array. Another example, k into bracket s plus 1 divided by s into bracket s minus 1, bracket complete, s square plus 4s plus 16. G of s is equal to is given. We can consider that h of s is equal to 1 unity and then calculate the values. Find out the number of roots, number of poles, number of zeros, angle of arrival, angle of departure, centroid or sigma, then angles, breakaway point we can calculate, and this is a diagram for that. With the help of this truth array we can calculate the k1 and the k2, and here it is written the stable range for the k is in between 19.7 less than k less than 35.7. It's stability for the k also. Then as we discussed all the things with respect to the root locus, it is very easy to draw the root locus for the given any closed loop system. Just we have to follow the steps and we can draw the root locus as we discussed the steps. Here it is. First one is a find out the steps. Once again we'll go through the steps. First you have to find out the number of zeros and number of poles. Then next one is find out the angle of arrival, angle of departure, then asymptotus, then centroid is there, then breakaway point we can calculate. Then we can calculate the with the help of the characteristic equation you can calculate the value of the k. These are the steps. Then we'll summarize the root locus in this way. The starting and ending point of the root locus is then rule number 2 is the number of branches, symmetry and the continuity of the root locus. Then third one is a root locus on the real axis. Always root locus or the loci is on the real axis. The sum of the roots we are supposed to calculate. Then asymptotus of the root locus, you can calculate the asymptotus with the help of the formula. Then breakaway point. For the root locus, you have to calculate the breakaway point, or we can say the BAP also for the breakaway point. Then the points where the root locus cross the imaginary axis, that also you can calculate with the help of the root theory criteria. Then we can calculate the angle of arrival and angle of departure. This is the summary for the root locus. Thank you very much.